Section 3.3, example number 2. Factor 6c plus 4c squared. First off here, I'm going to use algebra tiles. Before I use algebra tiles, I need to know what kind of tiles I'm dealing with. So I need 6 rectangles. 1, 2, 3, 4, 5, 6, and 4 big squares. So these represent my algebra tiles that I need to use for this polynomial. And remember, I need to arrange these into the shape of a rectangle. So I take those 4 algebra tiles, I play around with them, and I arrange them into a rectangle, which would look something like this. Crudely drawn. 4c squared plus 6c. And then remember that if we're actually using algebra tiles, it might look a little bit more like this. There. We've got our 4 big squares. What do we need? C squared? So c squared, c squared, c squared, c squared, and these are all c's. So now that I've got my algebra tile set drawn in a rectangle shape, I look at the dimensions of that rectangle, the width and the length. This dimension here represents x. This dimension here represents x. That would be 2x. Or in this case, c. Sorry. 2c. This dimension here represents c. This dimension here represents c. This is a 1, this is a 1, this is a 1. 2c plus 3. So my polynomial when factored would be 2c times 2c plus 3. The area of that rectangle giving us the polynomial that we started with. Okay? Length times width. Now I'm going to factor that polynomial using greatest common factor. 6c plus 4c squared. Come on. 6c plus 4c squared. I take my 6c, break it down into its prime factors. 2 times, oops, not 2 times 2, 2 times 3 times c. I take my 4c squared, break it down into its factors. It's going to be 2 times c times c. Well, what's common between both sets? 2 and a c, so it's going to be 2c. What am I left over with here? 3. What am I left over with here? 2c. 3 plus 2c. And I think I just realized that I may have, actually I did write it backwards. I wrote it differently up here, only because I started with my x squared tiles here. I started with my x squared tiles here, and that's why it came out c first. But this order, 2c plus 3 or 3 plus 2c, there's nothing wrong with either of those orders. Generally, we try and keep our algebraic term, our algebra term first, but you won't be docked marked at all. So you just need to realize that you can have them in either order. Okay? So there's factoring 6c plus 4c squared using greatest common factor. You might eventually be able to get to the point where, hey, you know what? If I know I'm factoring 6c plus 4c squared, if I know I'm factoring 6c plus 4c squared, I think to myself, well, what factor can I take out of 6c and 4c squared at the same time? I know they're both going to divide by 2. I know that I can divide both of them by c, so 2c would be my common factor. I would be left with 3c plus, or not 3c because I took the c away, 3 plus 2c. Now eventually you might be able to get to that point where you recognize all that, and that's a good thing. With some of these simpler questions, it's a little easier to see. The tougher questions, it is harder to see. I'd recommend using greatest common factor method. It definitely helps to lay it all out, especially once you're learning and getting practice at factoring these polynomials. Okay? So just as an extra, I'm going to say, you know what? Factor this question. Factor 2x squared plus 9x. And I'll give you a minute or so. I'll give you a minute or so. How am I going to do that? I can't pause the video because I don't know how to do that yet. So let's say at the beginning of the next video, I'll show you this answer real quick. So try that one.